Brad Williams, Frugal Finance, the frequency of compounding. Interest rates on loans and savings accounts are usually stated in the form of an annual percentage rate, 6%, for example, with a certain frequency of compounding, monthly, for example. Given that compounding frequencies change, it's important to find a way to compare interest rates. This is done by calculating an effective annual rate, EAR, which is the interest rate equivalent if compounding were to occur only once per year. For example, suppose your money earns interest at a standard annual percentage rate of 6% per year, compounded monthly. This means that interest is credited to your account every month at 1/12 the stated APR. Thus, the true interest rate is actually 0.5% per month. We find the effective annual rates by calculating the future value at the end of the year per dollar invested at the beginning of the year. Here's an example. Future value is equal to 1.005 to the 12th, which is equal to 1.06167778. That would be your EAR, or your effective rate. The EAR, I don't know why it's EARF, the EAR rate is the number minus 1, 6.16%. The general formula for EAR rate is 1 plus APR divided by M to the M, where APR is the annual percentage rate and M is the number of compounding periods per year. We did the same thing. The notation is different from what I discussed earlier. I was using the effective annual rate. Here it's changed. It says the annual percentage rate. So if you were to look at your credit card, you're going to see an annual percentage rate, 18%. And then hidden in the tiny, tiny print where you need a microscope or a magnifying glass to read the crap that these crooked banks do. For example, down here, you have a 18% rate, but the effective rate is 19.6%. Your APR is going to be 18%, noted right here, or the effective rate is 19.6. So anyway, back to the topic at hand. We have the effective annual rate. Compounded annually, it's 6%. If we start with 6%, semi-annual, 6.09. What are we doing? Here's the math. Look in here, and you're going to see the formula. Pretty straightforward. We've done this time and time and time again. All we're doing is taking the rate, dividing it by the compound period and the term. We're going to go C29, which is going to be the 6% rate. Divide this by the number of periods, which is going to be 2. Then we're going to take this to the power of, 2. And we're going to just subtract 1 in order to get this thing to show up at 6.09%. And we're going to go through, and you can see we can go quarterly, we can go monthly, we can go weekly, daily. And this is continuous compounding. This is the long way to do it. If you had taken that course earlier, you use the EXP in order to compute 365. But since if you didn't know that, here's the second way to do it. Let's say you're earning 6% per year compounded monthly. The stated interest rate of 60% is the annual percentage rate. The monthly interest rate, 0.05, right here, this is a repeat. You go up here, this is going to be 6.17. It's the same thing here. If we look at this formula, it's going to be the same. Simple. Here, it's hard-coded. You'll be able to see the numbers. 6% divided by 12 and monthly compounding. We have how many periods? 12. That's it. How much will I earn if I deposit $100 compounded continuously with semi-annual interest at 8% for 3 years? So I said E, so there's your E. That's going to be your exponential or EXP. 100, we're going to use the shortcut EXP, 8% divided by 2. Why? Semi-annual. For how long? This said for 3 years. 2 times 3 is equal to 6. Semi-annual compounding. That's how you come about this. Discounted back, 0.0783 is the factor, and that'll get us back to 100. There's that factor again. What did we do different? Well, we divided that same formula by 1. Then you can multiply this 127 times this factor, and it's going to get you back to where you started. Pretty nifty, huh? Present value, future value, sort of called parity. Moving on, $100 compounded continuously, semi-interest. All right, so here, and then we just repeated normal annual compounding. Here we have the simple formula. We just took 100 times 8% to the third. Then we just reversed it. See, we're multiplying here. Well, simple math. You're just going to do some algebra, and guess what? This is your discount factor and proof. 126, we have 100% compounded semi-annually. This is just semi-annual without continuous compounding. Notice the difference up here? We used EXP, and here we're just using a simple formula. And then 100 to be received at the end of 10 years, earning 20%. How much must I deposit today? So you need to put in $135.34 today, receiving, what did I say, 20%? Boy, if I earn 20%, I would be putting more than $1,000 or $1,000 into this. I'd be putting my house on this one. I refinance my house at 4%, take the money, put it in 20%. I think that's arbitrage. 16% arbitrage. Wouldn't that be great? You'd be living fat and happy and not having to do a darn thing. Credit card compounding, I've gone over this a zillion times. All we're doing is we're going to take 18 divided by 12. You're going to get a factor. You're going to use that factor and you're going to multiply it in order to come up with future value. You're going to add this together. It's going to be 1.196. That is the representative. All you need is the 1.5 to give you the number that will compound to this thing. Brad Williams, Frugal Finance, saying adios. See you soon.